So today time taken to cross door and people and one door and a door. Enter or exit once, taking 1 second. Non-decreasing. Okay. Okay, so they arrive non-decreasing. State. Okay. Same time. Exit goes first. Who wants to enter goes first. What the hell? So a bunch of rules, and there is 10 to 5 actions, so probably linear or n-log n time. So what do we want to do? Non-decreasing order. Okay. So if two or more persons want to use at the same time, right? If it was not used, then the person wants to exit goes first. So I probably need to keep the exiting people. Was used in the previous round for entering. Okay, so then first enter, if previous exit then exit, and if multiple want to go then smallest index. So I keep a queue, 2 queues for exit and enter people, and then time of last action, right? So times are 0 to n, that's fair. Okay, and okay, so let's see. So last time -2. This is because the first action can be 0, and if I would have -1, that would mean that something happened in the previous action. So this is last time, and then there is a last state, let's call it 0, it doesn't matter for now, and then we have queue int exit enter. Okay, so let's say our time is 0, and then time can go up to what? Well, if everyone wants to leave at n-1, then they are gonna be done at n2n-3. So arrival size let's do let's have like a list of people at a certain time. So I don't know, let's call it like people, and let's say with size of n. So we just store people arrival I push back I. So what this does is we store at people I tells me what people arrive at the door at time I. Now we go through each time and well, what do we do? First we check if someone came, right? So let's say we have 2 queues to make this simple to work with. So first we go over indices of people at this time, and then we do queue state index push back index. Okay. So if last time under t-1, then we need to keep the answer. So if not exit empty, then ans push not exit, but what state 0 first it wants to enter. So first exit 1. So if q1 is not empty, then we put q1 front and then q1 pop. Else if q0 empty, ans push back q0 front. That means then if no one wants to go outside, then if people want to go inside, they can go, right? Otherwise something happened in the previous round. So if and I want to say that the last state is exit, last state is this, and something happened, so last time is t and last time is t, and else okay, else something happened in the last round. So here is what we are gonna do. So if entering, then we first check if enter. So so let's see, this is the So this is the order we check. So if last was entering, we first check entering people and then exiting people. So we want to do this. But if last state was exiting, then we want to swap the order, right? And now we just go through both of them and order, and then what we do? Well, if not qk empty, then we do ans push back qk front, and then qk last state k, and then last time t, and we also break. And I think that's about it. We just return ans. Rival size. Some other bug. Q push. Oh, you cannot. Okay. I mean, I guess it makes sense. You cannot reassign an array, but. Should work, almost works. So only one person wants to end, so this guy goes out, right? He wants to enter, right? So let's say, so that person wants to enter. So we push him in, and then this happens, and then this does not happen, and whatever, right? So last time t, and then last state. So last time 0, current time 0, and then last state was an enter, right? So now two new guys come in at time 1. So I push them based on their state. This is not true, so we go here. The order is this. Previous was enter, so the one that wants to enter should go first. Wait, what? What am I outputting? The second, and oh my days. Okay, I'm outputting the wrong thing. Whatever, I guess. Do they guarantee that entering or exiting to follow? Okay. I guess it works in a way that the answer is just this. Okay, I guess ans time is this. Fair enough. No. Ans qk front is t. q1 from this t 0, so like this should work. Yeah, let's see. Okay, that was just simulation, so just simulation, simulate what the problem statement wants with two queues, one for exiting people and one for entering people. First let's save all people. Let's group all people by their arrival time. Then let's iterate through time, keeping the last action and the last time someone entered or left or exited. First we add all people that come to the door at time t to their respective queue based on their state. Then we just make a person pass based on the rules. If there is any person waiting, of course. And since each person is added and removed from one queue at exactly one time, and other work is O1 per time unit, whatever, and there are space complexity on, since there can be at most on people waiting at the door in one way, at the door at one time. Okay, this was, I'm not sure why this was a hard problem, to be honest. Let's check discussion. What do they say? Yeah, easy problem. Pretty simple for a hard, more medium level. Let's see other solutions. Python to DQs. You don't even need DQ, bro. Hey, that's the same without the first loop, it looks like. Yeah, and I'm rewriting previous state a lot, but okay, who cares? Goodbye.